First 25 problems. Give me one more. 30. First 25. Let me first clear, then we'll go to the next. First 25. First 25. Let me clear. I will go again. 9. Give me a stop. Stop. One booklet, please. कोई तो एक बुकलेट देना यार. हद हो गई.
Sorry.
Somebody is speaking and the mic is off from your side.
Sir, 18 sum.
Okay, listen.
And third. Sir, 45 and 47.
Many times I told you people among the first 25. Again I will take the next. Will you wait?
Sir, 24. Sir, 23.
Okay, listen. What do they mean? Doubts hai nahi, to why am I wasting the time? Why do students want to leave? How are they going to take the major test without the doubts of electrostatics? I don't understand. I take the doubts, you will leave. I don't take the doubts, you will insist me for doubts. बड़ा अजीब खेल है यार. Doubts नहीं लिया तो didn't take doubts. I take doubts, you will leave. Now listen. Somebody said first. Two identical conducting spheres having charges of opposite sign attract each other with a force of this. Now force is equal to K Q1 Q2 by D square. And quiet please. Right. Spheres are connected by a conducting wire which is then removed and therefore they repel each other with this force. The initial charges on the spheres. Now when you connect the two spheres with a conducting wire, this will become Q1 dash, this will become Q2 dash. Q1 plus Q2 will be equal to Q1 dash plus Q2 dash. This is my first equation. This is my second equation. What will be my third equation? Third equation he is telling you the repulsion between them. K Q1 Q1 dash Q2 dash by D square. Now this is the repulsion. Three equations. Right? Here it is attraction. Total charge is conserved. And listen. This will be the repulsion. Why will they have so much of a charge? Because Q1 dash and Q2 dash will be giving me K Q1 dash by R1 which is not given, which you don't require also. Radius of the two spheres are not given, right? Right? Two identical charges. That means Q1 is equal to Q2. That's it. Three equations and three variables. Q1 equal to Q2 is 1. Q1 dash and Q2 dash are the two variables. Second.
Sir. Sir, can I go? They're not letting me go. I've already done the exercise and I've done my doubts. I have no doubts.
कौन सा सेक्शन से यार ये बंदा?
Sir, batch.
Right on यार. Doubts are not yet over. You also know. I also know. You haven't done the exercise.
No, I have, sir. I have.
Then get them cleared. Sit down. HCV को भी हो जाएगा. बैठो. HCV का doubts will be taken.
Sir, I have no doubts for SCV, sir.
Come to this class once. Come here. उसे ऊपर ले आओ.
Yes.
एक बार HCV का questions पूछ लूँगा. अगर हो गया तो निकल जाओ. Question number 2. Two identical point charges are placed at a distance of L. Two identical point charges are placed at a distance of L. Sit here once. I'll ask you one or two questions. Second question you have solved?
Yes, sir. I saw it.
Solve it on the board. Come. Second question. Second question.
I think this, it's, I think it's, you can look at the graph on it, it should be right.
That's what, explain it to them why.
Well, sir, it says that E is plotted against X from a value close to 0,
Right.
which means you're close to one of the point charges.
Uh,
So at that point, you could say that R is 0, that's why field is, field tends to infinity.
okay,
And
then
then you go,
the center.
yeah, when you go towards the center, the field cancels out, and by the time you get across to
So
the
now
other
you have two options, C and D.
Yeah, so it should be, because at the beginning it was tending to infinity, then it goes to 0 in the center. And
How about this, A?
No, so that can't be,
Why?
because it has to go in opposite directions, the field.
Perfect. Now here the field will be in this direction, here the field will be in this direction, though this side it will be positive, this side it will be negative. Right, Beto? Right. Why do you want to run away? I don't understand.
No, sir, I have I have a doctor's appointment.
And then if capacitors was taught, your doctor's appointment would be cancelled.
No, sir, I had a doctor's appointment, I had to go anyway, so.
Okay, proceed then.
Can I go, sir? Thank you, sir.
Next, third question. 6 charges are placed at the corner of a regular hexagon is shown. If an electron is placed at the center, force on it will be. Third question, the question asked is very unreasonable. Take the resultant of all the forces, that's it. Somebody asked third. Why you have asked third, I don't understand. Third question, please take the resultant forces, that's all. Fourth question, have a look at it. 4 equal positive charges. Here play it smart, it is playing with 3D geometry. Please concentrate. If you are taking the distance from here, it is of a cube. Equal positive charges side L, Z axis. Now this will be Z axis, this will be of side L. So this distance will technically be, the total diagonal will be L root 2. L root 2 by 2. Right, L root 2 by 2. Now this will be 90 degree. Right, this will be underscore under root Z square plus L by root 2 whole square. So will I get the field here because of this? It will be like this. Can I get the horizontal component? Can I get the horizontal component? The vertical component of this will get cancelled out with the vertical component of this. Vertical component of this will get cancelled out with the vertical component of this. E cos theta parameter into 4 is the expression for field along the axis. Right? E cos theta into 4 will be expression for field along the axis. Are you getting this point? All of you? That's it. For that you know how to draw the graph. Once you have this expression, differentiate this with respect to the variable and equate it to 0. Differentiate it with respect to the variable and equate it to 0. Right? Why? For you to get the maxima. Then you will get to see that the maxima will be at L by 2. And hence you will recognize the graph. Right? Is this clear to all?
So, Dadar,
Yeah.
so when I did this question, I got an expression that we used to get in disk. So,
डिस्क नहीं, डिस्क कहाँ से यार? डिस्क is sigma. Expression for disk.
No, sir. In terms, so I got the same expression of the form of the disk, and then I compared it. So, is it right or wrong to do it?
डिस्क में सिग्मा आएगा ना यार, सेम एक्सप्रेशन कहाँ से आएगा? Please don't do such type of things. Right? Don't.
Okay, sir.
डिस्क में सिग्मा आएगा, they are point charges, no way comparable. Don't. Right? Now fourth, fifth problem. Sixth I have done in your class notes, please refer to it. People who are asking sixth as the answer, doubt, it is there in your class notes, please refer to it. Right? Fifth, charge per unit length. See, we have done for a semicircle, yes or no? Do we know the expression for a semicircle? Say something. 2k lambda by r. For a quadrant, it is the same logic. Consider an element. This is theta. This will be d theta. I will have dE this way. This will be dE sin theta. And this will be dE cos theta. You integrate them. You will get Ex and Ey. Now 4 quadrants ka resultant you can take. Yes or no? All of you. This was the fifth. Sixth, very unreasonable. It has been solved in the class in detail. What if it is a finite? What is it is a semi-finite? For finite, we have solved for alpha and beta. Yes or no? Same thing, just to substitute the values. You people are asking it as a doubt. Please attempt the problems before you ask that as a doubt. Put beta is equal to 0, it becomes a semi-finite wire. You exactly get the value.
So in the fifth one, will the field outside the ring would be 0?
Outside the ring, किस लिए चाहिए यार? Why will it be 0 and what is that?
Just asking, sir, just asking.
Don't.
So just
Let us
asking.
first finish the booklet doubts. Then we will think of the other parameters. Right? Outside the ring need not be 0. Need not be 0. Right? Question number 7. Two equal negative charges are fixed at the points. Two equal negative charges are fixed at the points A comma 0, 0 comma minus A. Positive charge released from 2A comma 0. Positive charge Q. Please find out the potential here because of this and this. Because of this, the potential here, I know this distance, right? Because of small q, can I find out the potential here? Because of small q, can I find out the potential here? That will be V1. Now because of both the charges, find out the potential here. V2 minus V1 into capital Q will be equal to half mv square. You release that from here. He is asking you what will its velocity be when it is passing through, executing, moving, origin, infinity. Here he didn't even ask for the velocity. You can directly tell us the answer. It will not be an SHM because this distance is not very small. It will be periodic and oscillatory. He didn't even ask you for the velocity there. 7th question. Is that clear? Nine. 3 concentric metallic shells. 9th question. Have a look at it. 3 concentric metallic shells. This is A, this is B, this is C. Minus sigma plus sigma minus sigma. Minus sigma, sigma minus sigma, right? Potential of the shell A is, find out the charge on this. This will be minus sigma into 4 pi A square, sigma into 4 pi B square, sigma into 4 pi C square. Right? Now because of this, the potential on this. Because of this, the potential on this. Because of this, the potential on this. Can I find out? Because of this will be KQ1 by A, KQ2 by B. Whatever is the potential on the surface, everywhere inside it will be the same. KQ3 by C. Sum of all the 3 will be the answer. That was the 9. Is it clear? Whoever asked the 9. 10. Class notes once again. Did I deal with this? Stable equilibrium? No. Listen. This is important. This is a ring. Have a look at it. The field because of the ring will be like this. It will be maximum at a height of A by root 2. Now what is stable equilibrium? Stable equilibrium is the situation when from the equilibrium if you slightly displace it, it will come back to the equilibrium position. Now watch out for this. If by chance I found the equilibrium position here, that means EQ will be equal to mg. Net force has become 0 here. From the equilibrium position, if I slightly displace it above, from the equilibrium position I slightly displace it above, mg will remain constant while this field will decrease. So there will be a restoring force pulling the particle back to the equilibrium position. Yes or no? Vice versa, suppose I pushed it down, mg will remain constant and dq will increase, so it will push it back to the equilibrium position. Can I call this stable equilibrium? Vice versa, have a look at this. Here if the particle is in equilibrium, eq is equal to mg. Now suppose I displace it from the equilibrium position in the upward direction, E will further increase. It will accelerate the particle in the same direction. mg remains constant. This is equilibrium position where eq equal to mg. You further move it up, E will further increase. If E further increases, it will be pushed in the same direction. So this will be unstable equilibrium. A point above this where field is maximum will be an equilibrium, then that is stable equilibrium. If you find a point here which is in equilibrium, that will be unstable equilibrium. You can see that by displacing it in the downward direction also. mg will remain constant while field will decrease. So the force in this direction will increase. So if you displace it from the equilibrium in the downward direction, it will continue to move. So this will be unstable equilibrium. This was question number 10. This is important. Can I rub this? Wait. Now, somebody said 13. Have a look at the 13th question. You have a field in this particular direction, mg by q. mg by q is the field. Theta, m and q. This is M. Field into distance. 11th is field into distance will be delta V. Field will be sigma by epsilon naught. Because of one sheet, it will be sigma by epsilon naught. Infinite non-conducting sheet of charges has a surface charges. Separation between two equipotential near the sheet where there is only one sheet. Separation between two equipotential surfaces is D. Right. So field into D will be delta V. This into this will be delta V. Field into distance. Now only single sheet is there. So sigma by 2 epsilon naught. Now 13 theta. This is M and Q. Have a look at it. Field is from higher potential to lower potential. This is L. This will be L sin theta. Field into L sin theta will be delta V. This is delta V. Potential difference. That into Q will be the loss in potential energy. Loss in electrostatic potential energy. Plus mg L into 1 minus cos theta. This is loss in gravitational potential energy. Right? Is this a thin rod? The rod is massless, right? If by chance rod is given mass, loss in gravitational potential energy must be taken even for the rod. This I will equate it to half I omega square. here.
So we could do it with G effectives method, like
Your energy conservation. Loss in electrostatic energy plus loss in gravitational energy should be equal to gain in kinetic energy. What makes you say that this is loss? Field will be from higher potential to lower potential. When the bob is coming by this particular distance, it is moving by a horizontal distance of L sin theta. Right? That was 13. Oh, 11 they asked.
Sir, wait. Done.
Sir, you could tell that loss in electrostatic energy once again.
Field into distance will be delta V. Delta V into Q is potential energy.
So loss.
Higher to lower, the field is from higher to lower. So this point will be at higher potential, this point will be at lower potential. When it is coming from here till here, it is loss in electrostatic potential energy. Have a look at it. Here you have some charge fixed. 14. This is distance A and this is distance 4A. This is given a velocity of u. Observe this carefully. This is the center. Suppose if this particle comes to rest here for the velocity that I have given, then if the particle comes to rest here, this electrostatic repulsion will push it back. Now this will have a vertical and horizontal component. Agreed? So this electrostatic repulsion will pull it back because it will have a tangential like this. So if I want it to complete a circle, this should be given so much velocity such that it crosses this particular point. The moment it crosses the point, suppose I come on this side, the electrostatic repulsion will have one normal and one tangential. The tangential will make it complete a circle. So conserve the total energy here, half mu square plus k capital Q small q by this distance is 4a. This amount of energy should be given so that it reaches this particular point. At this point it will be kinetic energy will be 0, potential energy will be k capital Q small q by a. Equate this quantity to this quantity, you will get the answer for the 14th one. Conserve the total energy at the initial point and this point. If you are giving it half mu square plus k capital Q small q by r, this is the potential energy here. If it crosses this point, naturally the field lines are radially outwards, right? The moment it crosses this point, it will have a component in this direction which will pull it out. So I don't need to give it energy for it to come till here. If it crosses the center, that is surplus. So at the center I want the kinetic energy to be 0. I think I am solving the 15. Yeah, at the center kinetic energy is 0. Potential energy is V into Q. What is the expression for V? K capital Q by 2R cube 3R square minus. This is how much? R by 2 whole square. This is the expression for potential into Q will be the potential energy. Equate this total energy to this energy, you will get the required answer. Now listen, next they said was 17. Charged particle Q held fixed, another charged particle of mass M and charge Q released from a distance of R. Impulse of the force.
Sir, 16.
1 second. 16. A conducting sphere of radius A has a charge Q on it, enclosed in a neutral conducting spherical shell of radius 2a and 3a. This is a shell. This is 2a, this is 3a. Find the electrostatic energy of the system. Self energy of this, self energy of this, self energy of this. Interacting potential energy between these two and between these two. I repeat, please observe, self energy of this Q square by 8 pi epsilon naught 3a, self energy of this minus Q whole square by 8 pi epsilon naught 2a, self energy of this Q square by 8 pi epsilon naught a. Now interacting potential energy between these two, K Q into minus Q by 2a. Because of this, whatever is the potential on the surface, everywhere inside it will be the same. So very technically I will write this as K minus Q by 2a into Q. Minus Q by 2a into Q plus interacting potential energy between these two. It will be KQ by 3a into Q. Because of this, whatever is the potential on the surface, everywhere inside it will be the same. Now interacting potential energy between these two, KQ by 3a into minus Q. Because of this, whatever is the potential on the surface, everywhere inside it will be the same. This is the total electrostatic energy of the system.
So when just conducting sphere is given, then we have to take it follow or
Makes no difference for you because if it's
Ah,
conducting,
in
always
this
charge will
case
be on the outer surface. Do you got? No, 17. Impulse, change in momentum. Capital Q is held fixed. Right? Fixed. Small q of mass m is released from a distance of small r. Impulse of the force exerted by the external agent on the fixed charge. Impulse of the force exerted by the external agent on the fixed charge. By the time distance between this and this will become 2r. You released from here. When it comes to a distance of 2r, right, can I find out the velocity? K capital Q small q by 2r minus K capital Q small q by r will be equal to half m
मैंने कुछ नहीं इस बार क्या उधर कुछ नहीं लगाया
Andheri, wait a minute.
Shell, then what we have to consider?
Empty, hollow. Shell by definition is hollow.
And conducting.
Why you consider conducting or non-conducting must be true. Shell means it is hollow. Would be conducting.
Conducting or non-conducting.
Yeah, compulsorily it should be true.
How do we go about that? I'm having trouble with electrostatics. I don't know how to.
Everyday reciprocal notes पढ़ना है. Compulsory. Notes go through it. Everything is covered in your books.
How do like solving sometimes there's something tough.
Now that we are discussing, how you understand?
Right.
Is everybody back? Hi. Okay. Yeah, 17th problem we were discussing. Capital Q is fixed. Small q is released from here. Right, capital Q is fixed, small q is released from here. When it comes here, I can find out the velocity. Loss in potential energy. Loss will always be initial minus final. Will be equal to gain in kinetic energy. Once I get the velocity, impulse will be change in momentum. Change in momentum on this or this, both will be the same. M into V minus 0. Here M into V initial momentum is 0. That will be the impulse on this. This will have an equal and opposite impulse in the opposite direction. Right? Seventeenth, that was. Now 18. Regular polygon of n sides. Identical charges are placed at n minus 1. At the center the intensity is E. Potential value of E by n. Listen. Always follow this technique here for regular polygons. Observe this. I have got charge Q here, Q here, Q here, Q here, Q here and Q here. At the center the field will become 0 because it is a vector quantity. Please pay attention here. The field will become 0. THANE please listen. Thane, please listen. Right, field will become 0. Suppose I remove one particular charge, then I will tell you field because of 1, 2, 3, 4, 5.
KQ by R square.
Right, field because of 5 charges plus field because of the removed charge. Sum total should be 0. He is asking you to calculate this. Calculate because of this and put a negative sign. Now there are n minus 1 sides, you have put up a charge q. Right, for n polygon of n sides, can I calculate what will be the distance between each of these charges this way? For 6 I know the distance. For 4 I know the distance. Use it in terms of n. Will I get this particular distance? Then calculate the field because of one single charge after knowing this distance. Your job is done. Put a negative sign for that. While you cannot do this for a potential, because potential is not a vector quantity. You will have to add the potential here because of all the charges. You will have to add the potential here because of all the charges. Is that clear? We have discussed the 16th, 18th, then they said 21. 21. Q and minus Q. This is the field. This is theta. Right? M is the mass of the ring. It remains in equilibrium on a rough inclined plane. That means there is friction. Hence, preferably take the torque about this particular point. Taking the torque about this point, I will have mg in this direction. I will have EQ taking the torque about this. mg cos theta. I am taking the torque about this. So, this will be mg sin theta. I am not worried about mg cos theta. Why are you taking the torque about this? There is friction. Then field into minus q will also give me 0 torque. Torque about point of contact. Torque about point of contact. Friction and EQ will give me 0 torques. mg sin theta into this distance are clockwise. EQ will be in this direction. EQ into this perpendicular distance. Right? Can you calculate that?
So 2 R sin theta.
2r sin theta. Right? So this will be equal to the net total torque EQ into 2r sin theta. That's it. I have taken the torque about this particular point so that I could eliminate the torque due to friction and EQ. Yeah.
Sir, what is the direction of force on minus Q?
Downwards. Downwards. Field is in the upward direction.
Thank you, sir.
Negative charge will experience a force in downward direction. Third and 24th. 23rd, you have one dipole P2, another dipole P1, theta R, right? Energy minus P1 dot E. E will be because of P2, I will have ER this way, E theta this way. Now P1 and this will be ER because minus P1 dot E theta will turn out to be 0 because E theta and P1 are perpendicular. ER value because of P2. ER value because of P2. Substitute, you get the answer. ER, do you remember the expression for ER?
2b2 cos theta by r cube. 2b2 cos theta by r cube.
Sir, why is P1 into E theta 0?
Perpendicular, dot product of two perpendicular vectors. E theta will be this way. You have given P1 this way, E theta will be this way. They are perpendicular. (24). You have 3q charge here, minus 2q, minus 2q and q. Now have a look at it. Suppose I take minus q and 4q. 3q is the net total charge here. Can I take it as minus q and 4q? Yes or no? Now 4q I split it as 2q and 2q. 1 2q and this 2q will give me one dipole moment. This minus 2q and 2q will give me one dipole moment. Minus q and q will give me one dipole moment. P2, P1 and P3. Take the resultant of all three vectors. 3q, I put it as 4q minus q. 4q is 2q and 2q minus q. Minus q and q will give me one dipole moment. 2q and minus 2q will give me one dipole moment. Minus 2q and 2q will give me one dipole moment. Resultant of these three dipoles.
Sir, 33.
So 39. 39.
Sir, 39.
Sir, 36.
Sir, 45. Sir, 35.
39.
30. 44. 34. 50. Sir, 37. Sir, 37. 42.
Okay, listen. 28. Figure shows a non-conducting ring. 28. Figure shows a non-conducting ring with positive charge on one side and negative charge here. Positive and negative charge non-uniformly distributed such that the total charge is 0. Potential at all the points on the axis will be 0. Fair enough, because the distances of any small element will be the same from the axis. Electric field at all points on the axis will be 0. No, need not be. Electric field कोई disconnect हो गया?
रिकनेक्ट सभी एक साथ करना होगा, छोटी फ्रेम में अटक फ्रीज हो गया, फुल स्क्रीन में दिख रहा है, स्मॉल स्क्रीन में फ्रीज हो गया। सभी को बोल सीधा और यहाँ था कट कर दिए। हाँ नीचे ना बोल। कनेक्ट मत करना तब.
अंधेरी के बच्चों को मैं दिख रहा हूँ.
हाँ तो 2 रूम में दिख रहा है. ये यहाँ का छोटा स्क्रीन फ्रीज हो गया है. फुल स्क्रीन में दिखाई देता है बराबर से. इसलिए कॉल रिकनेक्ट करवा रहा हूँ पूरे.
1 second wait. Shell is hollow, sphere is solid. Right, listen. 28, the charge is non-uniform. So the potential anywhere will be 0, but the field will not be 0. Right? Field by the components don't cancel out because of non-uniformity. Direction of electric field at all the points will be along the axis. That is true, it will be along the axis. Right? Direction of electric field at all points on the axis will be along the axis. Why? No, it need not be. Right, if the ring is placed inside a uniform electric field, then the net torque force acting on the ring would be 0. No, need not be. Non-uniform charges. Non-uniform.
Sir, can you please explain the field, why field will not be 0?
Now
Also
here,
the D part.
see, I will take a small element, because of this the field will be this way. It's horizontal and vertical components. Now vertical components will cancel out with a component on the other side if and only if these both charges are equal. Now here we have a new trouble. Not only they are unequal, but also they are not of the same charge. This side is positive, this side is negative. So negative side field will be in this direction. So it will, vertical components add up and horizontal components cancel out. So here one component will exist for sure, even if they are uniformly distributed. One side positive, one side negative. See, if my right hand side is positive, left hand side is negative, along the axis, because of the positive charge I will have the field this way, because of the negative charge I will have the field this way. Right? Because of the positive charge I will have the field this way, because of the negative charge I will have field this way. So this component cancels out and this component will add up. Clear? One side is positive and one side is negative.
So then field will be perpendicular to that axis.
If it is uniform. Now he is telling non-uniform. Right? 28, is it clear to all?
Sir, D option.
Ring is placed inside. Obviously the charge is not uniform. If it were a proper dipole, if I have a dipole minus Q and Q, uniform field means the force will be 0. The charge is non-uniform. Twenty-six. Positive charge, spherical cavity displaced by distance L. See, inside a spherical cavity, the field is dependent only on O dash. If this distance is taken as L, rho L by 3 epsilon naught, inside the spherical cavity, the field will be dependent on rho L by 3 epsilon naught. Right? Now 26th, right, positive charge placed in a spherical cavity. The center of the sphere and cavity displayed. Force on the charge will be Q into this. It will be towards the center. This was 26. 29. A point charge Q located at the center of a hollow sphere. Point charge Q located hollow sphere of inner radius R1 and outer radius R2. Potential at the inner surface. Potential at the inner surface. This will be minus Q and Q. Q is located at the center of a hollow spherical conductor of inner radius R1, outer radius R2. Conductor being uncharged initially. Potential at the inner surface. Right? Potential at the inner surface means this is a metal. All throughout the metal the potential will be the same. Q and minus Q will cancel out the effect here. The potential will be only because of this KQ by capital R. For any point outside, whole of this charge will appear to be at this particular point. That is the way these both will cancel out the field everywhere outside. Right? So these both will cancel out the field here. The field will be only because of this, or the potential is only because of this. He is asking the potential. What is the answer for 29?
D.
None of these. It will be KQ by R. This is 29. (31) A and B are two concentric spheres. If A is given a charge Q, two concentric spheres. A and B are two concentric spheres. If A is given a charge Q, which is of in a smaller radius here. B is Earth. Right, this is given Q. Now the charge density on A and B, have a look at it. This will be minus Q, this will be 0. Right? A and B are two concentric spheres. I will call this R, small r. I will call this capital R. I have given Q charge to A. This will be minus Q, this will be 0. Agreed? K Q by small r. Why are you doing all that? The charge density on A and B are the same. Charge density need not be the same. Field inside and outside A is 0. Field inside and outside A is 0. Wrong. Field will not be 0. The field between A and B is non-zero. Fair enough. It should have been more clear whether A is the smaller sphere or bigger sphere here. 31st May there is a small confusion, but yet you can answer the question assuming one of the stances. It should have been clearly told which is smaller sphere and which is bigger sphere. Right? The field inside and outside B is 0. The field outside B is 0 for sure. Inside will not be 0. So I think he has the reverse of it this then. 31st May there is a small confusion. They should have clearly told us if A and B, which is smaller and which is bigger. Right? Then we can answer it properly, but I have assumed A to be smaller and B to be bigger, and I have explained. Do the reverse also. One among the two will be the answers.
So just one thing. The charge density on A and B, A has a charge of Q and B has a charge of minus Q, but densities are different, right? But charge on them will be, do we have to consider the negative charge? Now if they say if charge on A and B is same, not density, so will that be true or false?
Nerul, the girl who is speaking, I should hear to her. Kindly maintain silence. Please speak. You will have to speak louder. Pass on the mic to her.
Question number 31, the field inside B is 0. Can you explain that one?
31. If this is A and this is B, you have grounded this. This is Q minus Q0. Now the field will not be 0 anywhere inside. Here the field will be non-zero. You will have because of this. Here the field will be 0. Outside the field will be 0.
Okay, sir, thank you. Got it.
32. maximum electric field intensity on the axis of a uniform charged ring of here. You know at A by root 2. Yes or no? Substitute E maximum will be KQX upon A square plus X square to the power 3 by 2. Instead of X substitute A by root 2, you get the answer 32. 33. You have a charge Q here. Point C, point B and point A. P. Right? Work done in moving a charge from here to any of the three will be the same because these three are equipotential points. So you are moving a charge from here till here or here till here or from here till here should be the same. Right? WA will be equal to WB equal to WC. 33rd. Because all these 3 points are equipotential. Potential difference of any of this point from here will be the same. Thirty-fifth, 37th, 34th, the lines should be perpendicular to the equipotential surface. They will go this way, perpendicular. At the same time, they should be smooth curves. Right? They should be smooth curves. You cannot have curves like this. Sharp edges are not permitted for lines of force. That was 34th. 35th. You have a charge Q1 here and Q here. A thin metallic shell contains charge Q on it. A point charge Q is placed at the center of the shell. Another charge Q1 placed outside. All charges are positive. Force on the charge at the center is force on the charge at the center. All external charges put together will give zero force on it. The force on the charge at the center will be zero. Principal concept of shielding. All external charges put together will give us zero field inside the shell. You may say because of Q I will have negative charge induced on the inner side. Doesn't matter, that will be uniformly distributed. So that gives me zero on this. If charges Q by 2, 2Q are placed at the center of face and at the corner of a cube. Center of a face. Have a look at it. This is Q by 2. 2Q are placed. If charges Q by 2 and 2Q are placed at the center of the face and at the corner of a cube, Q are placed. This we have solved. You will have Q by 8 inside. Now this will be half inside this, half inside that cube. So this contribution of this inside will be Q by 8 epsilon naught. Contribution of this inside is Q by 4 epsilon naught, because Q by 2 will be shared by both the cubes. So this will be Q by 4 epsilon naught plus this one will give me Q by 8 epsilon naught. Sum total will be the answer. Sorry, 2Q is given as it. What is the question number? 36. It seems this value is given as 2Q. 2Q means this will be 2Q by 8. Solid state chemistry में they tell you about it. 38, 34 and 5. 34, we have done 34. 35 we have done. 39. 37. 3 charges, right angle triangle. Net electrostatic energy of the configuration will be 0 if capital Q is capital Q, small q minus q. This is A and this is A. K capital Q small q by A. K capital Q minus q by this is A root 2. A root 2 plus K small q minus q by A. Sum total should be 0. Find the value of capital Q.
Both the charges are positive.
Q and Q are positive.
Yes, sir.
Then put plus here. You will get capital Q to be negative. $38 is pure chemistry. So many grams of iron will have 6.023 into 10 raised to 23 electrons. 2.24 milligrams will have how much? Right. So then you know 0.02% of the electrons are removed from it. What is the balance charge? $39. Observe this carefully. Here I want the field inside. Because of the total, what is this distance equal to? This is R, this is R. Am I right? Tell me if I am taking it wrong. R and R, right? So let me draw it rationally. This is R and R. Total field here because of the complete sphere. Rho 2R by 3 epsilon naught. Field here because of the complete sphere. Minus field because of the removed part. K small q by 2R whole square. This point is external to the removed part. Right? Minus field because of this removed part, that will be 0. Field because of a sphere at its center will be 0. So this removed part, if you remove, that will become 0 here. Agreed? Substitute for rho, you get the answer. 39. Field because of the complete solid sphere here, minus field because of the removed part here, minus field because of this removed part. This removed part will give me 0 field at its center. 39th is a very catchy problem. Substitute for rho, you will get the answer.
This second term is subtraction of which field?
This sphere's field here will be second term. This sphere's field here will be the second term.
Sir, will you please re-explain the problem?
Total sphere's field here is rho r by 3 epsilon naught. R will be 2r. The removed cavity's field here is this. This removed cavity's field at its own center will be this. Total complete sphere's field here is this. Minus field because of this removed part here will be kq by 2r whole square. Q will be the charge of this, the removed part, minus field because of this removed part at its own center will be this. Agreed?
Yes, sir.
42, you have got field lines this way. 42, you have got field lines this way. This is minus Q and Q. This is A and B. Right? Now his question, torque in the plane of the paper and no resultant force. Here listen, this is not a uniform field, so force will be non-zero. Torque will be non-zero. P cross E will exist. Right? P will be this, P cross E, clockwise inwards. Torque will be clockwise. right? What else does he need? That's it. He is asking for resultant force and the torque. Resultant force will exist. The field here is greater than the field here. Hence the force on A will be greater than the force on B. Torque will be clockwise, perpendicular, inwards. (44 and 45). Charge Q2 distributed over two concentric hollow spheres of radii small r, capital R, such that their surface densities are equal. Potential at the common center. See, this will be small q, this will be capital Q minus small q, divided by 4 pi capital R square twice, such that their surface densities are equal. That means if this is R, this is capital R. Q by 4 pi R square is Q minus Q by 4 pi capital R square. First equation. Right? Next equation, I want the potential at the center. K Q by small r. K capital Q minus small q by capital R. This is my answer. Find out small q from this equation. Substitute small q here, you get the answer. This was problem number 44. 47. 45. Uniform electric field exists in xy plane. 2, 2. This will be A. B is minus 2, 2. B is minus 2, 2. C is 2, 4. C is 2, 4. A is given as 4 volts, 16 volts, 12 volts. Field is from higher potential to lower potential. I get the field along the y-axis. Higher potential to lower potential, I get field along the x-axis. 16 minus 4 divided by the distance here is Ex. 12 minus 4 divided by this distance will be Ey. That's it.
So both should be positive, right?
By negative.
16 minus 4, 12.
See the directions. Ex will be positive, Ey is negative. Higher to lower.
And one more thing, can't we do it by Ax plus By?
Anything can be done. This is more easy to visualize. This is 12 volts, this is 4 volts. 12 minus 4 by distance, I'll get the field in this direction. Why did you take negative direction? Higher potential to lower potential. This is 16, this is 4. 16 minus 4 by this distance, I will get the field in this direction. This was 40.
Sir, can you repeat it again? There's too much noise in the class.
Which batch? NERUL, please maintain silence. NERUL, please maintain silence. See, 12 volts, 4 volts. 12 minus 4 by this distance, I'll get the field in this direction. And why did you take it downward direction? Higher potential minus lower potential. 16 minus 4. 16 minus 4 divided by this distance. Higher minus lower, I will get the field along this direction. Ex and Ey. Observe this. This is a plate. This area is what is enclosed inside. How do I get this charge here? This is capital R. This is X. So this radius is R square minus X square. Charge density on the plate is sigma. Sigma into pi R square minus X square will be charge by epsilon naught. Will be the flux through this particular surface. 47. This plate inside the spherical surface will be of area by r square minus x square, that into sigma by epsilon naught, that into sigma by epsilon naught. Fine with that? 48. See, for a thin wire the field is 2k lambda by r. For a cylinder also the field will be 2k by r, sigma into r, sigma charge per unit area will be sigma, charge per unit length will be lambda. Divide both, I will get length by area to be sigma by lambda, length by area. Now lambda will be sigma into area divided by length. Now lambda will be sigma into area divided by length. Area will be curved surface area, 2 pi RL divided by length is L. All that I have done is, even for a cylinder, 48th problem, the key catch is even for a cylinder, the field outside will be in the same format of 2k lambda by r. Even for a cylinder. Can I rub this? I will derive it for a cylinder so that you people will get an idea. 48, if this is a cylinder and I want the field at a distance of this, let this be of length L. I want the field at a distance of r. Assume a Gaussian surface like this. Assume a Gaussian surface like this. Field into the area. Right? Cylinder has a charge density of sigma. Now closed integral E dot ds will be equal to the charge density sigma into this curved surface area 2 pi RL. L I will take this particular length. This is infinite long cylinder. L is the length of the Gaussian surface by epsilon naught. 2 pi RL. This will be capital R. This will be small r. Sigma 2 pi RL by epsilon naught. 2 pi L will go. E is equal to sigma by r epsilon naught. Did I do it right? Capital R by small r. Right? So this is the field because of the cylinder. This is the field because of the wire. Both should be equal and opposite for them to cancel out. Right? Equate both, you get the answer. Equate both, you get the answer. In terms of sigma and r. This is the field because of the cylinder at a distance of small r. Radius of the cylinder is capital R. 2 pi got cancelled. Yeah. Capital R by small r. Field because of the cylinder at a distance of small r. Field because of the cylinder at a distance of small r.
Survey.
Field because of the cylinder of radius capital R. This is small r. Closed integral E dot ds is equal to sigma 2 pi RL by epsilon naught. E into 2 pi small rl is sigma 2 pi capital R L by epsilon naught. E is sigma capital R by small r epsilon naught. Make it fast.
Sir, what do you say it is similar to infinite?
No, man, now that we derived it, you don't need the shortcut. Actually, I thought I'll use the simile between sigma and lambda. Now you already derived it. 50th, 1 microcoulomb charge is uniformly distributed on a spherical shell given by the equation x square plus y square plus z square is 25. What will be the intensity of electric field at a point 1, 1, 2? Where you know the distance, no here. KQ by R square.
Divided by area of the sphere.
Right, point is inside the spherical distribution. KQ small r by capital R cube. Is this? 0. Oh no, spherical 0 na yaar. Anywhere inside the shell. Field is 0, 50th. Now very sincerely I want to listen to one answer. After a 10 minutes of a break, if I continue with exercise 2, 3, 4 doubts, how many of you will stay? Kindly raise your hand. Okay, Andheri majority are staying. Pune, nobody, one student raises his hand. No, नीचे देखो Pune BSNL. Does that imply the other students, one second, does that imply the other students have not solved 2, 3, 4 exercises? Say something. But then, suppose if next week we don't have a class, because our class is on Saturday. Suppose if we don't have a class, how will you get those doubts cleared? Fine. Now either way we cannot go ahead with capacitors. Right?
So doubts.
Doubts we will complete. Listen. What can be done? Nothing can be done. Right? Have 5 minutes of a break. I will be taking exercise 2, 3, 4 doubts of electrostatics after the break. Right? The others, see, these lectures will not be uploaded. Please come to the center, meet the respective staff member and get the doubts cleared. People who have not done exercise 2, 3, 4. Clear? If you have a doubt lecture, it is better we complete it next week, whenever, wherever we have got. People who have done it, please stay, get your doubts cleared. Whose book is this? Yeah, NERUL speak.
Sir, can you please send the link of the video?
Today's doubt lecture video. Okay, NERUL we will send.
Yes, sir.
We will send this doubt lecture.
Thank you, sir.
NERUL ko bhi. Sirf NERUL.
Sir, please send to NASIK also.
Sir, please upload it. It gets uploaded on Pencil.
No, that also we will. That they have stopped.
Sir, Pune branch RJ, can you send it to Pune too?
Okay, all centers we will send this.
Thank you.
Exercise 2, 3, 4 we will continue.